Welcome to Scene from Above, Season 15, Episode 3. In this episode, Sabrina speaks with Swetha Kolluri, who works on AI and digital innovations at the World Bank. Previously serving as Head of Experimentation at UNDP in India, Swetha has dedicated her career to applying frontier technologies to social and environmental challenges. With her background spanning rural development, data science, and sustainability initiatives across India and the US, she brings unique perspectives on transformative solutions using AI and cloud computing. In this conversation, Swetha shares insights from her work designing innovative development experiments and her vision for how Earth observation, citizen science, and AI can address global challenges such as environmental degradation and climate change. She also shares some tips managing cloud costs for organizations who may have low resource bases.
So, Swetha, could you share a little about what you're working currently on right now at the World Bank?
Sure, Sabrina. Thank you for inviting me here. This is my first podcast ever. So before I begin, I have a short disclaimer. So I'm here in my personal capacity to share my experience and not as a spokesperson for any organization. So I'm happy to talk about my work, but all the views that are expressed here are personal.
Sounds great.
Okay, and now to your question as to what I do. I work on digital and AI innovations for climate smart agriculture at the World Bank. So I work for a global team of the World Bank in Washington, D.C., called the Digital Agriculture Team that promotes digital and AI innovations in several World Bank investments across Asia, Africa, and Latin America, basically the developing countries. So my work involves thinking around both adaptation and mitigation in agriculture and how digital innovations can solve for it. As you may be aware, for the longest time, the climate adaptation took over most of the discussions on climate action in agriculture. But recently, people have come to realize that, and also quantified, that the emissions from agriculture are much higher than before. In fact, a third of global carbon emissions are from agriculture, and there are cost-efficient solutions to reduce them. So now the World Bank is focusing more on how to reduce the emissions in agriculture, particularly the methane, nitrous oxide emissions as well. So my focus in my work has been primarily to promote digital AI innovations that can incentivize small farmers in developing countries to switch to the emission reduction, regenerative agriculture practices. So these are practices that involve, like, let's say, lowering the tillage. Zero tillage is of great advantage. Similarly, lowering the methane emissions in paddy through direct seeded rice as opposed to transplanting of rice. So there are many ways to do that through agri-science. But however, how do we incentivize the farmers to do all these actions? So this is where climate financing mechanisms come into the picture. But for climate financing to be made available to farmers, you need very high quality evidence on the ground. You also need to prove that the emissions are reduced due to the farmers' practices, and it can be attributed clearly to these practices. And this is where the monitoring, reporting, verification protocols come in. As some of you might be aware, climate financing is a complex field, and MRV is a time-consuming process. For many people in the global south, it is prohibitively expensive, particularly when you have small farm holdings, like in the context of India and many other countries in Asia. So this is where we are bringing in digital innovations to reduce the transaction cost, to improve the reliability and confidence in the evidence. So the geospatial world here must be happy to know that a majority of these digital solutions requires remote sensing, geospatial modeling, use of IoT sensors, ground truthing, AI. So in India, as well as in many other developing countries, innovators and startups are now coming up with digital MRV solutions to unlock carbon financing and carbon markets for small farmers. So what I'm doing these days is coming up with sort of a digital architecture, because World Bank also has the convening role. So we're coming up with a digital architecture like digital public infrastructure that integrates the environment and accelerates what the startups are already doing to solve for digital MRV. So we are doing it in such a way that the carbon financing becomes more, transparent, efficient, and accessible for everyone, particularly the farmers and the farmer cooperatives. If you just look at this whole scenario from the tech standpoint, a DPI kind of an environment for climate financing, carbon markets, it would require network protocols. It would require a lot of APIs. It would require data and applications to talk to each other. Now, some of these apps that I've been talking about, some of them, they decode project design requirements. Some others decode what MRV could be and how it can be done digitally and faster using geospatial and AI models. There are also apps for auditors, apps for issuance of credits, apps for marketplace, transfer of credits, apps for transferring payments into the farmers' accounts, and so on and so forth. So as a convener of this sort of an environment, we are creating a digital environment to bring all these sort of applications together and make the system more transparent overall. Yeah. This is where most of my energies are invested. So some part of it goes into the technology side, but a lot of it also goes in bringing partnerships and onboarding people.
Yeah, that sounds really exciting because you are interfacing then with both people who are stakeholders, you're interfacing with people who are technologists and experts in both the AI side, but also the infrastructure side for the technical environment that you're putting together. And then also, of course, the financing players also are interested in how you're setting up this environment. So could you share a little bit about the role that the cloud plays in such a project or such an environment? And as you mentioned, Geo AI, would you be able also then to, introduce to the audience this concept of Geo AI, as it might be new to some of them? So, and lastly, how does the cloud then allow for the computing power that's needed?
Yeah, like you asked about cloud, all my projects are built on cloud, because even in my current role and as well as my previous life at UNDP, I have experimented with many new technologies that involve IoT, AI, geospatial data, etc. And they have all been experimented on cloud because the advantage that it provides in terms of cost and scalability. And particularly when you are experimenting and developing a new use case, there are many unknowns, right? So you are at times not entirely sure how much storage you would need, how much computation you would require, and what would be the user load. You don't know whether it will take off or not. So there are so many unknowns when you are in innovation space and experimentation phase. So that's where the cloud, with all its, flexibility, scalability, becomes an easy option. So one of my early experiments in 2019, applying Geo AI technology for identifying hotspots of air pollution in India. Yeah. So Geo AI, as the name suggests, uses a combination of geospatial data and artificial intelligence algorithms to provide some insights in very plain language. So in this particular experiment, I have combined satellite imagery and AI algorithms to detect the brick manufacturing units. It is possible to detect these particular objects using satellite imagery and high resolution satellite imagery in this case, because the brick manufacturing units, they in India have a very distinct layout. But because of their distinct layout, the way they are laid out with the stack and all, it was easier to train the algorithms to detect such objects on the satellite imagery. And this experiment wherein we have collaborated with the University of Nottingham in UK, helped in detecting 47,000 brick kilns from space. Now, such a detection was first of its kind in India and for many other countries in global south. So it was an exercise which is almost impossible without remote sensing, because if an environmental regulator who wants to regulate such brick manufacturing industry wants to do a field survey, and they'll have to go to each and every brick kiln, and they don't know where they are because they're typically present in rural areas in large landscapes, and they can come up without any sort of permissions or documents, right? So it's very difficult to track where they are located, how many of them are operating, and what is the environmental impact because of their operations. So this is where we have collaborated with the University of Nottingham, and most of the tech happened on their premises. The university, like many other universities, has an excellent HPC facility, high performance computing, and which was all leveraged for the AI computations. So, so the university doing the heavy lifting on the tech side helped us quite a lot to build a pipeline downstream applications and provide them for the environmental regulators in India to take action. Now, these hotspots are important from the environment side of things, because there is severe environmental degradation happening at the brick kilns. The soil gets depleted after you set up a brick kiln on a piece of land. Similarly, the water table goes down, and the air pollution is a lot. It is unprecedented because these manufacturing units also use very, very poor quality of fuel and input coal. So there are a large number of problems associated with the brick kilns, as well as in the social development lens, because some of the poorest of the poor people also work here. So it really becomes a hotspot for so many development challenges. Hence, it was our obsession to identify these hotspots and reach out to people, and at the same time reach out to regulators in order to control the environmental degradation that is happening because of these industries. So yeah, in this case, Geo AI technology helped us pretty well. The whole system of object detection probably would not have been possible without having AI algorithms such as convolutional neural networks. In fact, for those who are not very familiar with convolutional neural networks, CNNs, they are a category of deep learning algorithms, neural networks, and probably you've already come across them in some way or the other. Whenever probably you have seen, Facebook or in social media or some of the apps that are doing facial recognition, right? Or image classification, types of cats. So this sort of image classification also happens through CNN. In this case, we are using them on top of satellite imagery to see where a brick kiln is located or not located. So, and this became a first of its kind experiment, which was bringing in a new technology, Geo AI, to India. And it has been picked up very well, received very well, and the environmental regulators have started acting on the insights that were coming from the Geo AI. But of course, like I said before, most of the tech was taken care by the University of Nottingham in UK on their HPC facility. When in the last year, we attempted a similar thing for another use case, which was polyhouse detection. For agriculture, these days, many countries have started adopting more controlled way of farming through growing crops in polyhouses. So we wanted to see how many such investments were being done, and if at all investments were being done, were they being converted into polyhouses or not. So for that purpose, we developed another algorithm which was doing polyhouse detection. And we did the same thing, object detection through satellite imagery, but this time we applied a model called SAM, Segment Anything Model, on cloud. So this is an open source model brought out by Meta. And so they have a data for good kind of an arm, which brings out many open source models that can be really useful for Earth observation. And the segment anything model is quite useful, right? Because it's a pre-trained model wherein to which you can, feed in your trained data in order to generate the output for a large area of land. So when we applied this, we were able to cut down on the research expertise and computational investments as well. So such pre-trained AI models like SAM offered on cloud will definitely reduce the research time and resources significantly moving forward. So if anybody is interested to solve things in this direction, I would highly recommend to go through this. It's pretty useful.
Yeah, that's great to hear that there's this opportunity to use the pre-trained models to really cut down on the time that's needed to get these projects up and running. So you mentioned already that in your previous role at UNDP in India as the head of experimentation, you also worked on several projects that involve different stakeholders, including citizen scientists. Could you share a successful example of what strategies you use to get that stakeholder buy-in both internally and externally on projects that involve big data and the cloud?
Sure. I think one of my favorite strategies that I have applied at UNDP was that of citizen science. This sort of a movement also started around COVID, where, there were lockdowns and people were not moving out, but there were big problems to chase outside. So there were some enthusiasts, volunteers who started associating in as small groups, and they started taking up data science challenges or data collection challenges on the ground. So I took inspiration from such movements, and even for some of the experiments, like I mentioned before, Geo AI, you need to provide the algorithms with training data, right? In order to come up with, let's say, large scale insights, you need to feed the algorithms with training data. And for us, this training data had come from citizen scientists, volunteers. Some were as young as 10-year-old and 12-year-old school kids. Yeah, so we used some of their efforts to produce the training data. Like for instance, for Geo AI, where I said that we've seen an output of 47,000 objects detected as brick manufacturing units. That means their lat-long coordinates were provided very accurately, almost 96% accuracy. So that was our output. But the input had come from a large number of volunteers, digital volunteers, who were looking at the satellite imagery, high resolution one, and also identifying the objects, basically labeling them. Whenever they see a brick kiln on a satellite imagery, they label them, right? So about 2,000, 3,000 such data points were collected from the digital volunteers and the citizen scientists. And that became our training data to generate and identify 47,000 hotspots. But the 2,000 were done manually through visual inspection and detection of objects by human being. So this is I think a typical way in which computer vision algorithms are also trained, right? And we did apply some protocols to make sure that the quality of the training data is good, by making sure that each frame of satellite data is passed through 3 to 5 people. So 3 to 5 volunteers were looking at the same image and they were pointing out to the objects. Then we take the majority score coming out of such human detection, and then improvise, fine-tune, distill the training data, and then we will put them into the algorithm. So this was our approach as to how we were using digital volunteers for a training of AI algorithms. And in another digital public good that I have developed during my tenure at UNDP was called DICRA, Data and Climate Resilient Agriculture. Now that became a very successful digital public good because it scaled very well. But when we started out, what we wanted to do is we wanted to demystify what climate resilience means in agriculture. And we were doing this through accessing, open data sets that are available globally, published by NASA, ESA, and many other credible sources. And we were bringing them, contextualizing them to India, and also analyzing the time trends and the patterns and everything. But to do all of this, we did not have a good amount of resource base to begin with, because experiments, like I said before, usually start with a very low resource base. We had like, $20,000. So that is what I had. But the ambition was big because we wanted to solve for about 10 million hectares of land in one of the states in India and showcase what climate resilience means for that particular state at the farm level. Yeah, so the ambition is big, resources were small, and this is where I have encouraged a community of data scientists to come in, collaborate, and help us out in terms of curating each of the data layers. So together we formed a small group of initially 5-6 people, and through references and word of mouth, and all of this was happening during COVID, lockdown, and people wanted to do more for the society. So this is where the efforts came in, and our community became a community of 100 volunteering data scientists. Yeah. At some point, managing so many data scientists was becoming a bit difficult for me as a facilitator of the community. But however, we did a good job in terms of, dividing them into smaller teams and then defining use cases in a very participatory method, because we did not appreciate the hierarchical structures. In a hierarchical structure, it's easier to get things organized and all. But this is a community of volunteering data scientists. So we organized ourselves as nice horizontal groups, which were talking to each other, connecting, and we also brought in mentors who can come in and advise on various aspects. So this went on for about 1 year, and at the end of 1 year, we were able to meet the ambition of defining what climate resilience means for a state in India and tackling the problem of lack of intelligence on climate for an area of 10 million hectares. So this was an interesting approach, right? And it was also a new approach for a context like India. We have seen volunteerism coming in so many different ways, but volunteerism coming in through data scientists connecting, collaborating with each other seamlessly. And a lot of activity can be seen on GitHub, because everything is on GitHub, all the code, all the data, everything is on GitHub. So you see people, cloning, forking the models, playing around with the data and publishing back. There is a active community interacting, engaging with each other and, building on top of each other's efforts. So here people are not really competing against each other, but they are collaborating in very many ways. So a lot of inspiration came during this time to me on how citizen science can solve for some of the most complex challenges if you have a decent governance structure and if you know how to manage such communities. So that inspiration took me to another, if I can, cite one more example.
Well, before we head out to the other example, I wanted to ask a follow-up question about this project. So you mentioned the citizen scientists who got together in smaller groups and volunteered their time to work on it. Was there also involvement from state or government officials from the state of India you were working in, or from other types of stakeholders? How did you also get buy-in from them for this project?
Yeah, definitely. In fact, the problem statement started from sort of a collective intelligence workshop wherein we had stakeholders coming from government, from nonprofit world, from academia, then from agribusinesses, startups, everyone in the room. So there were like 40 diverse people, organizations in the room. And then collectively, we decided to build this sort of digital commons and digital public good, which will demystify what is climate resilient in agriculture and also make it as an open source for everybody to access, because more, we have enough number of data silos in the world, right? So data sitting in small, small pockets, not talking to each other is a problem that we see in all the sectors. So this is an important challenge, a sticky problem that many stakeholders were interested in cracking. And that's the reason why we started building digital public good. So buy-in, of course, the problem, right from the problem statement to the journey throughout the implementation, had participation of a large number of stakeholders. So I spoke about the 100 data scientists who were volunteering for this initiative. But at the same time, we had about 10 organizations that had come together, including government organizations, including agriculture universities, because digital alone cannot solve for it, right? So you need the agri-science input. Otherwise, geospatial will go in one direction, giving one sort of insights, wherein the field insights, the agri insights are very different from it. So it's a very, I would say, collaborative effort from various quarters. So buy-in, receiving this sort of a buy-in externally was not very difficult because, all the stakeholders were involved at all processes of the journey. So even when this digital public good scaled up from one state in India, a state in India is almost like a country, right? The states are pretty big. So when it went from one state in India to 7 other states, again, the stakeholders were part of it. They chose which states we want to scale up to. So all decisions were taken as a collaborative. So that's why in this case, citizen science as well as the data collaborative approach became very important. And they are one of the reasons why it became successful.
You mentioned you had a third example to share.
Well, yeah, just building on, all the inspiration I've received from the citizen scientists, and I thought there is a lot more to unlock. So I tried another experiment called Vayu, which is an open digital stack for air pollution, wherein I thought maybe, why not give like a portable air pollution sensor to our citizen scientists who can move around and tell us how the air pollution is panning out in a hyperlocal context like that of a city. Because air pollution is often seen as a wide area problem, right? An airshed problem which runs across states of India and sometimes crosses borders, right? So you ask one state of the India, why don't you tackle the air pollution within your state? They say that, hey, but it's coming from the other state. So you ask the other state, they will show that it's coming from a different country, neighboring country, right? So we wanted to break down this problem of airshed into what can be solved within the jurisdiction of a city and throw a picture of a hyperlocal context and pinpoint the sources of air pollution instead of saying that, okay, this whole city has got so and so and so metrics. Instead of that, we can say that, hey, these are the 100 and 1,000 points that are critical and that are causing air pollution more severe than the others, so that some sort of a prioritization can be done, right? So with that sort of a mandate to do hyperlocal mapping of air pollution, we came up with another experiment. So I always use the word we because it's not just me conceptualizing things out of thin air. So it's always me and, as part of UNDP back then, and also with a large number of stakeholders, government, like you said, academic partners, businesses, etc. So we came up with this open stack for air pollution called Vayu, which again took the digital public good kind of an approach. All data, all code, everything is published transparently online. But this time, the data is coming directly from the citizen scientist movements. So there are a bunch of young people, about 100, people, who came forward and they said that we will help you with the data collection at a very hyper-local level. So what they do is they carry a portable air pollution sensor on their bike, and then they go around in the city in certain designated routes. So we have an algorithm that tells them which pockets to cover. So they have a certain route that they subscribe to based on, the route that they usually use to commute. So every day they are driving in a certain route, and the sensor is picking up the points, the air pollution parameters, and they are sent to our cloud, and that is where the analytics happen. And then we also have a data science team that further looks into this big data, looks into the patterns, and tries to narrow down on the point sources of air pollution. So this is the intervention, and the environmental regulators are particularly very happy about this way of working, because then they can take very specific actions, or let's say at the 100 priority sites within a city, right? So instead of randomly doing that at so many different places, they can prioritize few sites, and they know what the sources are, and then actions can be far more customized and optimized, because in developing countries you do not have too many resources to solve for the whole. Usually you have to solve for 100%, but you've got only 5% finance to do that, or 5% resource to do that. So prioritization becomes very important. And that's what the data science and algorithms do in this case. And it is possible only through citizen science, because of the volunteers going around. We have built sort of a civic IoT movement, wherein the IoT sensors are pushing data to the cloud time to time. And that, along with geospatial data and many other sensors, we are able to pinpoint and say what is happening at the hyperlocal level.
Yeah, that's excellent. And you mentioned also before in the other project that you were working on that resources are a challenge at times. And I'm sure you have come up with some, creative ways of controlling the costs and budgeting for these projects to make them happen. And this is a really common challenge that many organizations face. And there's a lot of uncertainty sometimes around planning for cloud computing costs even before starting their first project. So do you have any advice for organizations on how to estimate and manage costs for projects that involve cloud infrastructure?
Yeah, sure. I played around quite a lot with some of the options out there.
Excellent.
Yes. And Sabrina, like you said, I have also seen several organizations struggling through this decision. Do they go for cloud or not? Sometimes it's too complicated. So I've seen organizations just take a turnkey kind of an approach, and then ask the vendor to bring in everything, like bring the software, bring the hosting, bring the cloud, everything, right, as a package. But and I've seen similar trends in the places I have worked before. And since I was starting from a low resource base, I did not have the bandwidth to give like a turnkey expensive solution, right? So this is where I had to dissect, and I took the cloud costs onto my own project. So I was doing the direct procurement of cloud and hosting services. When we were doing DICRA project that I just mentioned before, our estimate was, hey, computing would be about $5,000 to begin with. But when we started utilizing it and we started onboarding our team members, the volunteers, we saw that the requirement is a lot more. Then we could scale easily to extend the facility or to double the facility, click of a button. And this is possible. And then sometimes you think that, okay, so many users will be using your application simultaneously, concurrently at any point of time. So you don't have a good estimate of the load. Sometimes you overestimate, in which case your option becomes very expensive. But with cloud, you can, pay as you go, and you have very flexi options, and you can change your requirements as you go. So if you have like pay as you go option on cloud computing is great. But over the period of time, if you have like good estimates of your storage, how much storage would you need, how much compute would you need, and what your network specifications are, then you can consider something called reserved instance, wherein you pay in advance. Yeah. And you pay much less in this case. So pay as you go vis-a-vis reserved instance on cloud computing. If you have a good estimate, go for the reserved instance. You will end up saving a lot of money. So I used reserved instances quite a lot because, the first year when you're running the experiment, you're not sure how much it takes. So you're flexible. But the year two, you have more degree of confidence as to what your specs are. Then it is better to go for reserved instances.
Yeah, thanks so much, Swetha, for sharing these insights. You also probably had a journey towards acquiring this kind of knowledge about cloud options and infrastructure costs. Could you share some tips about what good resources of information are out there that you found very useful on your journey to educating yourself about how the cloud generally works?
Mostly gone through the pricing mechanisms that are provided by service providers. They are more or less comparable, and I would say they have reached an equilibrium in the market. So I found the services very comparable, whether it is Azure or AWS or the Google Cloud. But it is not very straightforward, I would say. I had a bit of a journey myself, also testing it. Also learning it while I was experimenting, right? So so that did happen, but most of the information is available and easily consumable um, on the standard websites. So I guess that is where I spend my time, and also maybe talking to a large number of software developers and taking their experience into consideration.
Yeah, definitely. That's also a good idea. Talking with people in addition to doing your own research on the pricing and testing things out as you go. So when you are building a team for one of these projects, you mentioned, you have software developers on your team and data scientists. What kinds of skills are you looking for like your core team when you set something up?
So in the core team, in most of my projects, I used to look at more into the project design and the stakeholder engagement, forming data collaboratives, incentives, and stuff like that. But I always look for good quality data scientists. And data scientists also come with different varied expertise. Some of them are really good in natural language processing. Some of them are good in geospatial. Very rarely, actually, it is normally difficult to find people at the intersection of geospatial and comp science. And then computer vision, neural networks. So these are the specializations that I look for among data scientists. And then data engineers. I, of course, came to a good realization that data engineers are very important in terms of building the full stack, the data pipelines, APIs, and also advise on the cloud requirements. So I did not have large number of data engineers in my team in the past, but uh, yeah, I always look for volunteers with that sort of an experience. Then testers are important at the end of the day for reliability, credibility of any product. I think testers are very important. Then visualization folks, the storytellers and the visualization folks are also common in this space. And for causal analysis, since I'm coming from the public sector, some of the questions are in the direction of causality. How can you add X amount of input because of your project or your actions? So this is where I also associate with those with econometrics background or statistics background. And these days, I look for people who have played around with large language models. But what I'm seeing more often is that since large language and foundational models, they take care of the complexity of the AI to a great extent. AI deployment, roles around AI deployment are trending. Yeah. And so this is mostly on the tech side, but I also look for complementarity in skills in non-tech and subject matter domains. I look for multidisciplinary professionals, those who have done ethnographic studies, gender experts, and so on and so forth. Yeah, so I usually work with a diverse group of stakeholders. It's not only people who have got the tech background, but I also for those with interdisciplinary skills. And working in AI, I always make sure that there is someone who is championing ethics in AI, someone who is bringing in that sort of a lens. Because uh, time to time we need to address the problems around fairness, accountability, transparency, and ethics in AI. Yeah, so when I say my team, I don't recruit all these people. I look for collaborators and as organizations as well as individuals who can bring in new value perspective to the space.
Absolutely. And so we are coming to the end of our podcast, and it's been a wonderful conversation with you to hear all these great advice and insights and stories. And we ask all our guest speakers the same question, and we would love to hear your take on it as well. So, Swetha, is the future of geospatial in the cloud?
Is the future of geospatial in the cloud?
Yeah.
I think geospatial is the present is already on the cloud. I don't think it's the future. I think that's the present. Yeah, I've seen, many analysts move to Google Earth Engine during our times, Sabrina, which is an entirely cloud-based platform. And with the use of Google Earth Engine, we have seen how cloud plays an important role. And similar access, similar information is again present on AWS, Azure. Planet Labs is moving in this direction. So I think geospatial world is currently already on cloud, and moving forward, it may be only on cloud.
Absolutely. And it's time, I would say also, that we as professionals in the field also, start looking that way and, imagining ourselves in terms of what are the skills needed, both for our own careers, but also for people in our organizations that we might be working with. And it's exciting to see this transition happening in our generation.
Thinking about the future, I think in the near future, and of course, I'm seeing a lot of trends in the present as well. Geo AI would be important, wherein AI, as opposed to the traditional physics-based algorithms, is applied on top of geospatial data. I think neural networks can tackle nonlinearity and noise much better, and it is proven through computer vision applications time to time. So it will be good when the geospatial sector intersects a lot more with the comp science. That'll be a very interesting area. The accuracy would improve, like I suggested before, object detection, change detection, classification, or analyzing movements, risk assessments. All of these things will improve in their accuracy when the two fields intersect. So yeah, Geo AI to me is the near future. But another important future that I would like to point to is the geospatial foundational models. We are in the era of foundational pre-trained AI models. We are already seeing the disruptions in the traditional text analytics and NLP landscape. So similar disruptions can be expected in geospatial as well. We are seeing startups such as Clay. They're attempting geospatial foundational models where user can perform all the geospatial analytics through commands in natural language, just like the way we are speaking. Give a command in the natural language in order to get your geospatial analysis done. That's cutting edge. So, so Sabrina, for you and me, all the zillion hours that we have put toiling with, JavaScript, GDAL, all of that, I don't know if it will stay relevant or not. But this is good overall for the society broadly, because it will democratize the expertise which was concentrated in very few pockets before. So solutions will go faster. I think I think Watson X AI geospatial foundational model is also pretty good, and they have launched very recently. And the good news is some of these foundational models will be available as open source, right? And I'm placing my big bets on the open source to democratize expertise and knowledge. So yeah, so I guess this is where the world is moving. And but there is one thing for people who are looking at potential future careers. I would say, like other applications, foundational models themselves do not automatically solve for use cases. So so use case development, AI deployment, building applications on the cloud will stay relevant in the years to come.
Yeah, and it's definitely really exciting to see how humans can use AI to solve more problems and, take away the mundane tasks and use that freed up capacity to really think about more strategic or larger picture issues. And, also bringing in the right questions to ask, right? Like how right now with a lot of LLMs, the prompt engineering is really what can get you the right answer or really affects the quality of the output from the AI model. So probably the same with the foundational models, right? Like we need to still ask the right questions and give the right instructions
Yeah,
to come out with the actually useful answers.
we would need next generation educators like yourself, Sabrina, to teach the world how to navigate the space of foundational models moving forward.
Yeah, thank you so much, Sweta. This has been a really great time chatting with you. We're really glad to have you on the podcast. And we wish you all the best going forward. And we will continue to follow your career and the exciting projects that you're leading. So thanks again for appearing on our podcast today.
Thank you very much for hosting me. Thank you.